This lesson is going to be about writing polynomial functions from graphs and from certain criteria. So we're going to talk a little bit about the fundamental theorem of algebra. So that just means that any polynomial raised to some power will have that many roots, and they can be real or complex. So if we look at this first example, 2x to the fourth minus 3x squared plus 3x minus 10, we look at our leading coefficient. This is in standard form, and we can see that it has got a power of 4. So that means it's going to have 4 answers or 4 solutions. Remember that roots are the same thing as x-intercepts, which are also called zeros, or solutions. So those names are all interchangeable. So if I look at this 3x to the third plus 1, that means I'll have 3 answers or solutions. And those can be real or imaginary. Okay, so we're going to look first at a couple of graphs, and we're going to learn how to graph from, or write an equation from a graph. So we need a couple of points. We've already talked about this a little bit. This is an intercept form. Intercept form just means that it's already factored. So we're going to find our clear points. So here's some clear points. This point here, down here, is not very clear. We want clear, precise points. So we can notice here this is -8, 0. And this one here is 1, 0. And then our y-intercept is 0, -8. Now, we notice here that this curve, this -8, 0 at this root, this is a bounce. And we notice here that this is a pass. So we know that a bounce has got to be some type of even exponent, and a pass is just 1 because it's not a curve pass. So we can start with writing x, because that's a -8, we're going to write +8. And we're going to start it as a 2. It could be more, we don't know, but we're going to start out with a 2. And then we have x minus 1, and it stays as just a 1. Now, anytime we write these, we normally assume that the a is 1, but we can't just assume that because obviously they're not always 1. So we're going to put an a there, and we're going to use another point to plug in to solve. Now, when we do that, we have a little bit of leniency about what we pick, but we want to try to pick what's really easy. So the y-intercept, if we can see it, is super easy. So we're going to use that. So that's saying when y is -8, x would be 0. So we're going to plug in 0 for all of our x's, and then we're going to solve for y. So when we do that, make this a little bigger here, we're going to get 0 plus 8, obviously, is 8. 8 squared is 64. And then a -1 and 0 gives me a -1. So that ends up being a -64 times our a. So we got -64a is equal to -8. And then when I divide by -64, I end up a being 1/8. Now I can rewrite, because I want it in the intercept form, f of x. Let's use a different color here. F of x would be equal to 1/8, and then x plus 8 squared, and x minus 1. All right, I want you to look at 2 and 3, see what you can do on your own, and then come back and see how you did with the process. All right, so number 2, we had a root at -9, 0, and a root at -3, 0, and then I had another random point at -6, 8. So we have a bounce, so I know that we have a bounce. We're going to have a quadratic or an even number, and then we had another bounce as well. So I'm going to start with what I know, x plus 9 squared, so I'm using the 0 property to know that that is going to be a positive 9, and then x plus 3 squared. And then I'm going to use the other point, the -6 and 8, to solve for a. So when 8 is y, or the f of x, I plug in -6, and I ended up having the a value of 8 over 81. And so then I rewrite, and then this would be my final answer. Now, for the last one on this row here, we have a bounce, it's -6, 0, a curve pass, that's 4, 0, and then I picked another point that I clearly see. Unfortunately, we don't have the y-intercept on these. That is always the easiest to do because you can plug in 0 really quickly. So I know that this is going to be a 6, positive 6, and it's got to be squared because of the bounce. And this started as a 4. It crosses at the 4, so I know it's got to be a negative 4 in my factor, and it's a cubic because it's a curve pass. Then I picked the 2, negative 5, solve for a, and I got 5 over 512, and then rewrote this in intercept form. On the next section here, these are in words, and they're telling us what we have to do, and we're putting most of these in intercept form here. So the first one, write a cubic. So we got to know what the word cubic means. When we see the word cubic, we know that that means 3. In intercept form, that passes through the x-axis at negative 8, negative 3, and 4. So we're going to start with, we're writing a function, so f of x equals, so if we know we're passing at negative 8, that's really x plus 8. And negative 3 is x plus 3, and then positive 4 would be x minus 4. And it has to be cubic, so we look and we say, well, that's a 1, that's a 1, that's 1. Well, 3 ones is giving me 3, so that's cubic. That would be my final answer. Of course, you don't have to write the little ones. So let's look at number 2. It says write a quintic, and that means 5, so we got to know that, that curves past the root of 3 and bounces at the root of 9. Well, first we're talking about the 3, so we know we're doing x minus 3, and it's curving, so that gives me a cube. And then at 9 would be x minus 9, and that's bouncing, so that would be a squared. And I'm trying to get to a power of quintic, so 5, so 3 plus 2 is 5, so that would be my answer. All right, I want you to try the other two, and then come back and see how you did. So with number 3, we had that a 6 degree. We had a negative 2, so I know that's a positive 2. We had a 4, so we know that's a negative 4, and we had an 8, so we know that's a negative 8. And when we look at what it's asking us, passing through 4, we know that exponent's going to be a 1. Curving past negative 2, which means that's going to be a cubic, and then bouncing at 8, that's going to be quadratic. And they all have to add up to 6, so 3, 4, 5, and 6, they do. Now on this one, I didn't fully complete it. We're doing a quintic, and we want to have intercepts at negative 10 and 8. So negative 10 tells us it's x plus 10, and a positive 8 tells us x minus 8. Well, it doesn't tell us like which one is doing. We just know that the whole thing has to add up to 5. So we could actually have x plus 10 be 1. We could have x minus 8 be 4. Or we could have x plus 10 be 4 and this one be 1. Okay, and now I'm not putting a 1 there, but you know there's a 1 there. Or I could have x plus 10 be 3 and x minus 8 be 2, or vice versa, x plus 10 be 2 and x minus 8 be 3. As long as they add up to 5, it doesn't matter because they didn't give any other information. So any of these would be correct. All right, we're going to move on to the next section about writing polynomials equations, and we're going to do them in standard form. So when writing polynomial functions, we always write the functions first in intercept form, okay? In intercept form first, because it makes our life a lot easier. Okay? All right, so this one we're going to write in standard form. Remember, standard form is completely factored all the way out. Everything's multiplied out. We're writing a quadratic. We know a quadratic means 2 in standard form with one x-intercept at 9. Well, at 9, we know that's going to be negative 9, so x minus 9, and quadratic would be 2. Okay, so our function is f of x, and so if that was intercept form, we would be done. But it's not. We want to go to standard form. So that means we have to multiply these out. So x minus 9 times x minus 9. And when we do that, we get x squared. We're going to have a negative 9x and another negative 9x. So we end up with negative 18x and then a positive 81. So the f of x is equal to x squared minus 18x plus 81. That would be our final answer. All right, I want you to try this one and see how you do. So for number 2, we had to write a quartic polynomial in standard form. Quartic means 4. There are 3 zeros at negative 7, 0, and 3, where the function bounces at the origin. Well, if we think about what the origin is, we know that that is exactly where just x is. Now, we could also write that as x minus 0 to kind of help us and then simplify it later. Not necessary if you understand. So here I have my at the origin, so that's when it's 0. It's bouncing, so that's squared. And then x minus 7 will be plus 7, and then minus 3. We're going to go ahead and multiply them out, distribute out, and then what we get, our final answer, is here. Okay? All right, our next section is we're going to be writing polynomials with leading coefficients other than 1. So we got a few steps we're going to write out first. All right, so the first thing we're going to think about is we're going to use the root to write factors. We're going to write an A in front of the factors. We're going to plug in a random point in x and y. We love to do a point that they give us, if that's all they're giving us, or the y-intercept. We're going to solve for A, and then we're going to plug the A value back into the function. So we're going to do the first one together, and then you do a couple on your own. So we're trying to find a cubic polynomial. Cubic we know is 3. We're going to write in standard form, and we have some x-intercepts at -3, 1, and 5, and it also goes through this point that they have given us of 3, -12. So we're going to write with what we start first. So f of x, we don't know a, and we're going to write our roots. So we get x plus 3, x minus 1, and x minus 5. Now, we know that's cubic because our degrees add up to 3, okay? But we don't know what a is. So we're going to take this other point when y is -12, so the f of x is -12. X will be 3. So we're going to plug in 3 everywhere that we see x. And we're going to simplify. So a stays. We got 3 plus 3, obviously, 6, 2, and then a -2. And then we multiply those out, and we end up with a -24a is equal to -12. Divide by our -24, and we get a is equal to 1/2. Okay, so now we can plug that back in and start putting it in standard form. So now we know what the stretch is. A is actually your stretch, how it stretches and compresses and all that good fun stuff, just like any other transformation. So we all have f of x is equal to 1/2, x plus 3, x minus 1, and x minus 5. Now if we were doing vertex form, we could stop, but we're not. We've got to keep going. So I'm just going to take 2 pieces first and multiply them together. Doesn't matter which 2 pieces. You can do these 2 pieces, or you can do these 2 pieces first. Either way. So when I multiply here and here, here and here, I end up with x squared plus 2x minus 3. My half's still out there. I can bring that down. And then I'm going to do the same thing again. So there, I'm going to end up with all of them marked out. X squared, oh, not squared, x to the 3rd minus 5x squared plus 2x squared minus 10x minus 3x plus 15. Combine my like terms, I end up with x to the 3rd negative 3x squared from here and here, and negative 13x from here and here, and plus 15, and all of that gets multiplied by 1/2. So now I'm going to distribute the 1/2 all the way through, so I end up with 1/2 x to the 3rd minus 3/2 x to the 2nd minus 13/2 x plus 15/2. And all this is my function in standard form. I know it's in standard form because it's left to right with the greatest degree first. That would be my final answer. So if you'll look at number 2 and 3 in this section, try them, and then come back and see how you do. All right, let's take a look at number 2. We had to write a cubic polynomial, gave us the roots. I wrote this one as x minus 0 for the 0 so you could see that we could plug it in the same way. We're going to plug in the point -3 and 18 to solve for a, and we get a is 1/3. Now, I know when I am doing x minus 0, that's still just the same thing as x. So I moved it up here to the front by itself. And then I'm going to distribute out. combine those like terms, and I end up with my final answer there. On number 3, we had to write a quartic, which is 4, and it says it has zeros that bounce at 0 and 7, and it goes through another point. So again, I wrote it with x minus 0. This time it's squared because it's bouncing, and x minus 7 and squared because it's bouncing. Plug in an a. We're going to use another point, so I used the point they gave us, 2 and 4. Solve for a and got 1 over 25. And then here, plugged it back in. And then distribute it out to get it into standard form. And my final answer is here at the bottom. Now, our next section, we're going to talk about writing polynomials from graphs. And again, we discussed this, so this should be something that is just kind of a practice. So we want to find some true points for sure. Having our y-intercept is super nice thing to have. Don't always have that. So I'm just going to mark them. That's our y-intercept. We have a pass-through right here at -1, 0. Always make sure you're paying attention to the units and how they're done, that they're not counting by another number like we've seen before. And then this one's 8, 0. And we have this one bouncing. So we'll start the same exact way, just when we're given points. We start exactly the same way. So f of x, we don't know a, so we're just going to keep it a. But we know we can write this as x plus 1, because we're talking about it was negative root. And then it is just passing, so it's an exponent of 1. And then x minus 8, and that's squared. Now, we'll take another point. In this case, we have a y-intercept, so -4. We're going to use that to solve for a. We're plugging in 0 for x. Everywhere that we see x, we're plugging in a 0. So we end up with a, obviously just 1 there, and then a -8 squared is going to give me 64 equals -4. So when I combine that, I get 64a equals -4, and then when I divide by 64, I end up with a is a -1/16. I would then plug that back in and then factor completely out. So f of x will give me a -1/16 for my a, now that I know it, x plus 1, x minus 8, and squared. Now, when I have these, you can do it in any order. Just be careful and don't do just x squared and plus 64, because this means x minus 8 times x minus 8. And this was x plus 1. And you can do this in any order. I like to kind of get rid of these things first, is the binomials. So I have x squared. I know that my middle term is basically going to double. If you remember that quick place to show that, you get a -16x plus 64, and then you're going to multiply it by x plus 1, and then the -1/16. So when I multiply completely out, I end up with x. And when I do this, and for some of you that may be having trouble with adding, x is going to multiply times every piece, all the pieces. And I will write them as x cubed, and then -16x squared, and then plus 64x. I'm done with him. So now he's finished. So when I go to my next piece, here, my 1, I'm going to stack them underneath. Okay, so 1 times x squared is just x squared. We know it's plus because it's in positive. Then I have a -16x, and I'm stacking it underneath like terms. And that kind of helps me combine them instead of forgetting. So then I have x here minus 15x squared, and then 64 and a -16 give me a positive 48x, and then plus 64. And then all of that still needs to be multiplied by -1/16. And so my final answer will be f of x, a -1/16 x cubed plus 15/16 x squared minus 3x and minus 4. And so that would be my final answer in standard form for that graph there. All right, I want you to try the next one and then come back and check it. All right, so I took my 2 points. I noticed they bounced, so they're both going to be squared. I solved for my a and got 2 over 49. And I wanted to show you a little strategy to remind you if you're having trouble with trinomials and multiplying trinomials by trinomials, you could use the box method. I'm not big on methods, but this one's very helpful. So I went ahead and did x plus 4 squared and got x squared plus 8x plus 16, and I just wrote it at the top of my box, and I did the same thing for x minus 2 and got my answer. And now it's pretty simple to just multiply x2 and x2 and get x to the 4th. And then I'm multiplying x2 times 8x. And it's the same thing that you're doing. You just put it in a form that makes it a little bit easier to combine like terms. So I end up with being able to easily see what goes together instead of doing like a stack method or marking them out or whatever it may be. So when you get all your pieces multiplied out, you end up with this. And if you'll notice, we have just 1 to the 4th, but we have here, these are together. We have, oh, that should be a 2. That should be a 2. Sorry about that. Then we have, these are all 2's. These are linear, and then that's a constant. So we can then write it easily, x to the 4th. Combining those two, we get plus 4x cubed. Combining these pieces, we're going to end up with negative 12x squared minus 32x plus 64. Now, this still all needs to be multiplied by your a. So that's 2 49ths. So when we multiply it all out, we end up with 2 49ths x to the 4th plus 8 over 49ths x to the 3rd minus 24 over 49ths x to the 2nd minus 64 over 49ths x plus 128 over 49. This would be in standard form. So that's a large number. Now we should be able to see that that's a 4th degree. We can easily see from our leading coefficient here, it's a 4th degree, which means we would have one less turning point. So we would have turning points of 3, and I can go back up into my graph and I can see I have 3 turning points. It's also a positive a value, so it's a positive a. And because it's an even degree, we should know our end function, our end behavior is going to be a positive, positive. And if we look here, we do have a positive and a positive.